Hello, my name is Jeppe. In this module, we'll have a look at whether or not additive manufacturing is a sustainable production method. So the first obvious question is 3D printing actually a sustainable production technology? The right answer is maybe. Another answer could be it can be. It depends. Compared to what? I can only say that there's a lot of clever people having looked into this. There's been written books about it. There is organizations about it and many opinions. Anytime you manufacture something, it's not as such sustainable, but this is definitely an enabler for sustainable production. And I will give you some details on that. More things we can say about is 3D printing a sustainable production technology is that there has been written a lot of articles. I have brought a few of them here, a few of the frameworks that you typically use to assess the sustainability of production methods and of the sustainability of 3D printing. I don't want to go into details, but I have the references here, so you can look into the details yourself if you want further information. I can also only say that there's a lot of people claiming that 3D printing helps these sustainable development goals from the United Nations in a number of different ways. Again, I don't want to go into details, but I will come with some examples of how 3D printing is used as a sustainable production technology. One of the frameworks that I actually do like is this one from the article that I have stated here, stating some of the drivers for AM sustainability. You have a number of different enablers, as I will call them, because as such it is not a green sustainable technology, but it enables some of these features. For instance, weight savings. You can make lighter parts, improve product efficiency, for instance, oil coolers, heat exchangers with a higher performance, with a lower energy consumption. Part consolidation, so where you previously had maybe 20 parts, you collect that into one part and thus gain some benefits. Make-to-order manufacturing and mass customization, making individual parts for the individual customer on demand. And the final point in this graph here, production of spare parts and repairing, instead of completely replacing a really expensive and difficult to manufacture component like a gas turbine burner, you can just repair it using additive manufacturing, obviously gaining some sustainability advantages. I do believe though there are some features missing on this, so I added a few ones myself. Some of the non-technical and process related benefits that include a novel supply chain. So as we see in the figure in the lower left, you can go from idea to a part made at the customer in one step, where you would typically have a number of steps involving prototyping, production, assembly, distribution, storage, retail, before it actually comes to the customer. So it's a new kind of supply chain. You can also see you get the ability to make local production, so you actually print it at the customer or near the customer, thus enabling a reduced transport. You can reuse the material. It's a highly efficient, energy efficient and material efficient process because you only use the material going into the product. Finally, you can have files in stock and not products. And this is a really big issue today because you need to have spare parts for all your equipment to be able to service it really quickly. But some of the features that we are looking into is having files on stock instead of products. Now I have a number of examples showing how others have used additive manufacturing and 3D printing to enable a more sustainable production of the parts. One of the really traditional cases I have here, it's from a European project where they optimized some aeronautics components. And we all know this belt bucket from an airplane. The traditional one weighed about 155 grams. Using AM and optimization, it could be reduced to 70 grams. There is a large number of these on a plane, and if you multiply with that and you see how much fuel is actually used per kilo, you can see that over the airplane's lifetime you save 3.3 million liters of fuel. So that is one of the reasons why the automotive and the aeronautics industry has really adopted additive manufacturing because you can make these lighter components, thus saving a lot of energy, a lot of fuel, and a lot of money. The next example that I have with you is a case that we did at DTI a number of years ago, together with the Boeing company. It's a bracket. It's a piece sitting between the chassis and the motor blocks, or a rather flight critical part, where we showed that we could print this, and it was in compliance with this standard ASTM F2924, and it had a number of benefits regarding sustainability, because they looked into scenarios where they could quickly repair their flights, they could make the parts lighter, they could have files in stock, as I mentioned, instead of the physical parts. So they were looking at redesigning their supply chain actually. And we showed that this was possible with the current technologies. We also showed that you could use this phenomenon called topology optimization, where you simulate the part and the forces on the part, and through an iterative simulation process you remove all of the material that is not needed. In this case, we could make it stiffer, we could make the displacement smaller, and we could reduce the total mass by 35% from more than 300 grams down to about 200 grams. The next example, also from the aeronautics industry, because there are so many examples from there, is a really classic one also, the GE fuel nozzle that they use in their LEAP engine. It's a really famous case because it has so many benefits. So as we can see, they could reduce the inventory by 95%, make a 30% cost efficiency improvement, 25% weight reduction, do part consolidation, so it went from 20 parts down to 1 part, and make it 5 times more durable. All in all, reducing a vast amount of fuel related to a vast amount of money for them. So they are producing several hundred thousands of these parts. The next example is a case that we did at DTI in collaboration with Aarhus University and a company called Thürmer Tools. Thürmer Tools are making these cutting tools. You can see the traditional one here, weighing about 6 kilos. Again, doing topology optimization, so saying what are the forces and removing all the unnecessary material. We went with a design like this, weighing about 1.5 kilo. So again, we could reduce the weight quite a lot, and it's important because it's used in places where it's difficult to go, for instance on oil rigs or offshore wind farms. And it's really important to have the parts as light as possible. Furthermore, when we're talking additive manufacturing, the less material you have, the cheaper it gets, and the faster it is to print. So all in all, very beneficial. To give you an example where it's not in the aeronautics industry or in the tooling industry, we have one here from consumer goods. It's a rather new case where this company called Mauer is making these glasses, and together with EOS and the Fraunhofer Institute, they have documented that it is much more sustainable if you do the production with additive manufacturing. I've added a few links so you can see some of the news and some of the numbers behind it. But I like this example because it also illustrates that it is for all types of products, including these consumer goods. The final example that I have here is in relation to thermal applications, because there's so much potential within additive manufacturing enabling thermally optimized parts. Some of the examples we can see here, it's like heat exchangers, heat sinks, where these very advanced structures enabled by additive manufacturing enables more energy efficient products. At DTI, we have a project called ECE, where we look at thermal topology optimization with these partners. And in this way, you can make the absolutely most topology thermally optimized parts, saving a lot of energy. So I really do believe this is the future for thermally optimized parts. Final slide, just want to round off by naming some of these drivers for AM sustainability. Why is 3D printing an enabler for sustainable production, because I believe it all boils down to that. 3D printing enables more energy efficient parts, production of lightweight parts. It enables local and distributed production. It provides the ultimate flexibility in your production. It yields a short time to market. It can reduce overproduction. It yields material savings. It can reduce the scrap. And all in all of these things enable AM to be a more sustainable production method.